My name is Don Mercer, and I am with the Department of Food Science at the Ontario Agricultural College, University of Guelph. I would like to welcome you to this series of presentations on the drying of fruits and vegetables. In Part 1, we will examine the reasons why we dry fruits and vegetables. We will begin with a brief introduction and welcome, followed by several acknowledgements. After we review the goals of these presentations, we will look at the reasons for processing food and then the reasons for drying. We will wrap up this presentation with several summary comments. Welcome to this series of presentations on the drying of fruits and vegetables. It is a pleasure to be able to work with you and to assist you in increasing your understanding of how to dry fruits and vegetables. I would like to thank Mr. Andrew Goodwin, Associate Industrial Development Expert with the Agribusiness Development Branch of the United Nations Industrial Development Organization, for his considerable efforts in coordinating this project. I would also like to thank those who are assisting in the presentation of this material to various local groups. Their contributions to our training activities are greatly appreciated. So thank you for these efforts. This series of presentations is designed to provide information on the drying of fruits and vegetables, as the title implies. Emphasis will be placed on mangoes and tomatoes. Additional materials will be considered in order to expand upon the basics involving mangoes and tomatoes. These include carrots, apples, and hot yellow peppers, amongst other materials. Once you have viewed these presentations, you should be able to explain the reasons for drying food materials. You should also be able to properly prepare appropriate materials for drying. You will also be able to use safe food handling practices to produce safe, high-quality, dried products. Before we begin our examination of drying, we should take a very brief look at the reasons we process foods. We need to answer a number of questions in this regard. Of course, food spoilage is a major problem. It is estimated that 1/3 to 1/2 of the world's food supply is lost due to spoilage, and this is a tremendous waste of resources. Of course, we want to improve the storage life of these materials, which we also refer to as shelf life. Let's consider this tomato, which over time can go moldy and be rendered inedible. However, if we take something like this Roma tomato, we can process it in a canning operation and have a high-quality product even several years later. Another reason for processing foods is to improve their cleanliness. Simply washing materials is a fundamental processing step that should not be overlooked. High on the list of priorities for processing foods is the improvement of safety. Foodborne diseases have a major impact on the overall health and well-being of consumers. It doesn't take much to change a pleasant experience of enjoying a meal into an unpleasurable experience if foodborne contaminants are present. Of course, as we go through this, we have to be careful not to confuse safety and quality. They are entirely different things. We want to preserve quality, of course. If we begin with a high-quality sweet red pepper, or a high-quality apple, or high-quality jalapeno peppers, we want to maintain that quality over time and deliver this to the consumer in a consistent manner. We want to enhance the edibility and nutritional value of food products. In the case of Irish potatoes, the starch cannot be digested by humans unless it is gelatinized by heating. So unless we gelatinize the starch, we do not have the nutritional value that we desire of our food. We also need to match supply and demand over long distances. We may have a source of material that is separated by distance from the market for that material. So in order to deliver a product from a country like Canada to a country in Africa, or to take something that was produced in Africa and deliver it to Canada, we need to transport the product over great distances. And to do this, we need to have some sort of processing involved. In addition to matching supply and demand over distances, we need to match supply and demand over time. Let's consider a source of material that will be used in the future when there is a market for that material or a demand. This occurs quite frequently when there is an abundance of product during the growing season. However, in the off-season, when that product is scarce, there may be a need to import the product and pay increased prices for it. However, if we process the food at the end of the growing season and put it into proper storage, we can supply the demand that occurs in the off-season. We want to provide convenience and variety to the consumer. You may not be familiar with instantized potato flakes, but they are a really good example of how processing can provide a convenient food product. In this case, the potato is peeled, cooked, and mashed. Then the mashed potatoes are placed in a special dryer where they are converted into dried potato flakes. The dried potato flakes can then be stored for later use. When the consumer wants to use them, they simply add boiling water to a certain volume of the potato flakes, mix them up. Perhaps they will add something like milk and a bit of butter to make them a little bit creamier, and they have very quick mashed potatoes at a high quality in a very short period of time. Processing of food materials can take many forms. Drying is just one of them. Other methods include thermal processing, which is the application of heat. Canning is a good example of this, and we've mentioned that in a previous slide. So we take the Roma tomatoes, we can can them in a thermal processing operation and deliver whole tomatoes to the consumer at a later date of very high quality and safety. Fermentations use microorganisms to process food products such as milk. By applying specific microorganisms to the milk, we can convert that into cheese or into yogurt. We may also use chemicals in the preservation of food products. Salt is a very good example that comes to mind. In this case, you may be familiar with salted fish. Salt draws the water out of the cells of the fish and other food materials such as meat. And the salt that goes into the cellular tissues creates an environment that is unsuitable for growth. It should be noted here that salted food should be soaked in fresh water several times before they are consumed in order to reduce the salt content. Sugar is considered by many consumers to add to the sweetness of jam, but this is only part of the story. The sugar binds water in the jam and makes it unavailable for microbial growth. Acids can be added to foods to create an environment that is unsuitable for microbial growth. Acids such as citric acid, which can be sourced from lemons or limes, are ideally suited for food applications, as are other acids such as lactic acid and several others. Sodium sorbate, potassium sorbate, sodium benzoate, and several others are example of chemical preservatives that inhibit the growth of microorganisms within food materials. However, consumers are becoming increasingly suspicious of the addition of such preservatives to their food products, and they tend to shy away from foods which contain chemical preservatives. Other processing methods are available for use, but we will not go into them here. Now let's look at a definition of drying. Simply stated, drying involves the removal of water from food materials. We have several slices of mangoes in this photograph that are losing their moisture, and in this drying process they are converted to dried mango slices. This is done in a controlled manner to meet a desired final target water content. The target water content is decided upon based on a number of factors that we will consider later. However, we need to hit the target as closely as possible. With too high of a moisture content, the product can spoil. If the moisture content is too low, the product may have some attributes such as crispiness that are viewed as being unfavorable by the consumer. More details on drying will be provided later. We will answer questions such as how do I do this, or how do I do that, and what does this mean, and what does that mean. But first, let's take a look at the reasons for drying. Some of the reasons for drying food materials are the same as the reasons we process foods. There are also some additional benefits that drying provides. Of course, it reduces spoilage over time, which was done in the other processing applications. Again, we see the tomato, which can spoil by going moldy and become unusable or inedible. However, if we remove the water through a drying process and produce dried tomato wedges, as shown in this photograph, they will remain usable after a significantly long period of time. Water is a major component of the food we eat. You may want to think of the water in fruits as being the juice, and in this photograph I've shown a glass of orange juice. Water is a major factor in food spoilage. Taking a look here, we see a moldy beetroot, and we also see some moldy apple slices, and this mold growth is caused by the availability of water and nutrients that are contained within the food itself. Microorganisms that cause spoilage need water to grow. Here we see a photograph of a moldy mango slice. Chemical reactions that cause spoilage also need water to take place. An example of chemical spoilage can be seen in the case of a cauliflower. The fresh cauliflower in the photograph on the left of this slide has the characteristic creamy white florets that indicate a high quality fresh material. However, over time, significant changes can take place. In the photograph on the right, we see cauliflower that has aged at room temperature. You will notice that the creamy white florets have become beige or darker brown, and in spots they've almost become black. This is due to a chemical reaction that is induced by an enzyme that's present within the tissue of the cauliflower. The name of the enzyme is polyphenol oxidase, but you don't really need to worry about that. What you need to be aware of is that chemical reactions can take place in the presence of water under suitable conditions that will cause spoilage of the food. Mangoes contain 80 to 85% water by weight. Tomatoes contain up to 95% moisture by weight, and carrots contain about 89% water by weight. Peppers contain about 93% water by weight. Irish potatoes have about 78% water, and yams have about 74% water by weight. So as you can see, foods we eat have a high level of water on a weight basis, so there is a high level of availability of water for microbial growth and for degradative chemical reactions to take place. There are often natural sugars that are dissolved in the water in the materials that make this an ideal situation for microbial growth. The amount of sugar may actually increase as the fruit ripens. So let's draw a graph to illustrate this. On the vertical axis, we will put sweetness. On the horizontal axis, we will have time. We can consider an unripe mango which has a very low level of sweetness. However, as it ripens, the level of sweetness increases, and these sugars are actually available to support microbial growth in the presence of the moisture that is in the tissues of the mango. If enough water is not removed in the drying process, spoilage can still occur. Here we see some improperly dried stalks that were going to be used for animal feed, and in this test I did not remove enough moisture so you can see the abundance of mold growth on their surfaces. Water removal also lowers the weight of a food material compared to its starting weight. In the case of a mango, we have a mango weighing perhaps 300-400 grams, but after we remove the skin and the seed and dry the material, we end up with a much lower weight of dried mango slices. Now let's consider the example of fresh tomatoes. If we start with 100 kilograms of fresh tomatoes with a moisture content of 95% and dry them down to 10% moisture, we will get 5.6 kilograms of dry material at the end. We will explain this calculation at a later date. Similarly, if we start with 100 kilograms of fresh mangoes at 85% moisture, we will get 16.7 kilograms of dried material at 10% moisture, and we will explain this later. It should also be mentioned that we are starting with 100 kilograms of mangoes after the peels and seeds have been removed. So really we're just considering 100 kilograms of mango flesh. Weight reduction has a significant impact on the load capacity of small vehicles to move materials. It is much easier to transport dry materials than it is to transport fresh materials which contain a significant weight of water. Weight reduction is also significant in lowering the weight for shipping materials to other markets, particularly by air, and of course this reduces costs significantly. Many materials experience a volume reduction due to drying. Here we see some tomato wedges in a dryer before the drying operation has started. Note the size of the fresh tomato wedges. After drying, you can see the considerable difference in size of the tomato wedges. Reduced weight plus reduced volume allows more material to be transported in small vehicles. We can also experience some textural changes during drying. Fresh mangoes and dried mango slices will have obvious differences in their texture. Dried fruits tend to become leathery but still remain pliable. Dried fruits also tend to be chewy. There may also be textural as well as visual differences between unsweetened and sweetened dried mango slices. Here we have unsweetened mango slices that were prepared in a traditional drying operation and some sweetened mango slices that were prepared in a slightly different manner. And you can see that there is a distinct visual difference between the two of them, and there is also a textural and taste difference as well. Dramatic taste changes can occur due to drying, and this is especially true for fruits. Most pronounced amongst these taste changes is sweetness. Let's use an example to show what's happening. We're going to take 100 grams of fresh mango slices with a water content of 82.1%, and this is representative of mangoes that are available on the market. In this 100 grams of fresh mango slices, we will have 82.1 grams of water, 15 grams of sugar, 1.8 grams of fiber, and 1.1 grams of other components such as proteins and minerals, etc. There would be 15% sugar in the fresh mango slices. So let's show this diagrammatically. We have 100 grams of fresh slices containing 82.1 grams of water, 15 grams of sugar, 1.8 grams of fiber, and 1.1 grams of other components. And the important thing to realize here is that there are 15.0 grams of sugar, which constitute 15% of the weight of these fresh mango slices. If we dry these 100 grams of mango slices to a final moisture content of 10%, we would get 19.9 grams of dried slices. To do this, we have to remove 80.1 grams of water. Since there is no loss of solids in drying, we would still have 15 grams of sugar present. So showing this diagrammatically, we have 19.9 grams of dried slices, which contain 2.0 grams of water, 15.0 grams of sugar, 1.8 grams of fiber, and 1.1 grams of other components. We still have 15 grams of sugar present, but this now comprises approximately 75% of the total weight of the dried mango slices. Since the solids are not lost in the drying process, the 15 grams of sugar will be equal to about 75% of the total weight of 19.9 grams. This will make the dried mango slices taste much sweeter than the original fresh mango slices. Drying can be used to change the form of various fruits and vegetables. We see this in the production of raisins by removing moisture from grapes. The concentration of sugars in the raisins permits them to have a somewhat higher moisture content than the other dried fruits. In this photograph, we see plump grapes at the top and dried raisins at the bottom of the photograph. The grapes themselves contain about 82% water. When dried to produce raisins, the raisins contain about 18% water. And this is an interesting case because the raisins have entirely different applications than the plump grapes. Raisins are used in cooking applications, in snacking, as well as other applications. Special plum varieties may also be dried to produce prunes. The plums begin with about 86% water, and when they are dried down to prunes, the water content is in the range of 25 to 28% by weight. And it should be pointed out that due to the high concentration of sugars and other water-binding aspects, the water content here can be somewhat higher than it is in things like dried tomatoes and dried mangoes. Ease of handling is also a feature of dried food products. We'll consider mixtures of dried fruits and nuts as well as dried berries. In this photograph, you can see dried fruits such as dried papaya, dried mango, some dried pineapple, as well as raisins. Some dried berries may be in there, and you can also see various nuts. And this is called trail mix, which is a very popular snack that can be just taken in the hand and popped into your mouth one piece at a time. In the photograph on the right, we see cranberries that have been dried down to make a very popular snack that is consumed in North America. And these dried cranberries are rather sweet because of the manner in which they are dried. Convenience and variety are also important aspects of the drying process. Here we see some dried noodles and a dried spice mix. If we add hot water and stir the mixture, we end up with a quick, tasty meal. So dried noodles plus dried spice mix and hot water will give us a quick meal. If we make changes to the spice mix or to the noodles, we can increase the variety of this particular product. There may be other reasons for drying fruits and vegetables that you have in mind, and I would urge you to consider them. So in summary, we have now established the necessary background information regarding why drying of foods is important. Before examining the actual drying of such things as mangoes and tomatoes, we should look at the methods of water removal. How we dry fruits and vegetables, which is the next video in the series, will explain some of the procedures involved. Thank you very much.